We have a huge program for today, and I only wonder how you would like to go through it, because there is enough material for probably 2 more webinars, not just this one, since the topic is huge and quite complex. So we can either just flip touching the very surface of it, or I can go in more detail and just see how we go and postpone the rest till next time, so we can do it more thoroughly and there wouldn't be such huge information overload. I think probably it makes more sense, because I personally enjoy every single bit of information, and more thorough. Great. Yeah, I agree. And to start with, I want to say that when we are talking about electricity of brainwaves, when we are talking about the origin of brainwaves and their function, there is so much research done, and mainly the research happened in the last 30 years. So after 1990s, and especially since 2000s, it just went like this. And obviously, the information sources are different. And it's critical while studying this subject to find trustful sources of information, because obviously I'm not the scientist working in the laboratory and testing all of this potentials, etc. So it's hard for me to prove or to check or to verify through my own experience whether this is right or wrong. So please understand that I refer to the sources of information that were available to me. I also refer to my own understanding of this information as well, because it goes through my filters of perception and through my current knowledge and understanding. So if you by any means see that you know more, you can correct me, or if you later come across information that contradicts or complements what I will be saying today, please don't be shy, send me an email. And I think this is such a huge topic that probably it would be good to revisit it even each year, because there is more and more research coming in. Plus, I wanted to embrace so much information from so many information sources, not make it shallow, make it really deep, make it profound. Okay, here we are. Basic neurophysiology, brainwaves, origin and function. And today comes the day when we actually will be talking about brainwaves, origin and function, finally. So this is the continuation of the previous webinar, which was part 1, which is already available in the video gallery. And those who are present, you definitely received a recording link, which leads you to video on YouTube that you can replay to refresh what was there in case you need it. So highly recommend everybody to watch it if you haven't done it yet. To remind you where we finished last time, we finished on central nervous system building blocks and their implications for neurofeedback. If you remember, we simplified the central nervous system structure. So central nervous system will consist of the brain and spinal cord. So in the brain, we differentiated cortex, subcortical nuclei, and brainstem. So basically like 1, 2, 3, if you want to say so. And this 1, 2, 3, as we also discussed, can be associated with the head brain, or most intelligent thinking human brain. This is cortex. And then subcortical nuclei mainly will send us to limbic system, which is considered to be emotional brain, which is much older than our neocortex, our human brain. And then brainstem can be associated with reptilian or animal brain, which is basically responsible for our basic survival functions. And it's the most ancient brain that we have in us. So that was the structure that we were looking at. I also promised that we will start with finding a key word or metaphor for the main function of these major parts that I just named: cortex, thalamus, hippocampus, cingulate gyrus, insular brainstem, limbic system. So let's quickly refresh and see what I came up with. And if you have something to add, I don't know If you come from, if you are a medical doctor, or if you're a psychotherapist, or you come from any other area where you may know physiology much better than me, so please, you're welcome to contribute. And before we start, I thought I should definitely add this slide, because very often, if you're reading scientific literature, you will see the references to different parts of the brain. So anterior, obviously, it's that part which is in the front, posterior, which is in the back or behind something, superior is above, dorsal, ventral, they're more like spine and your belly, and then lateral and medial will show whether it's closer to the center or to the top. Dorsal ventral can go this way if we are talking about brainstem, and it can go this way if you talk about middle part of the brain. So anyway, if you are confused, look here for reference. And here is a funny chart that we may start with. So I think it will help you to memorize it in a fun way. So let's start with cortex. So prefrontal cortex, our thinking brain, center for creativity and logic. If you remember, cortex in general is responsible for lots of things. So to be precise, it's in charge of executive functions. If the executive is not clear, it means operations of controlling and monitoring of motor, sensory, and cognitive actions in goal-directed behavior. So these functions are mostly attributed to frontal lobes. However, the basal ganglia and some other subcortical structures are necessarily involved. So, of course, nothing lives in separation, and specific functions will depend on which part of the cortex. And we remember cortex is divided into lobes. Frontal is responsible for decision-making, problem-solving and planning. Temporal for emotions, memory and speech. Parietal for sensory processing, and occipital for vision and color. So in key words that I came up with were cognition, sensation, movement, behavior, language, thinking, planning, organization, control, and metaphor that I came up with. It's kind of head office, it's thinking brain, it's administration, which decides what, where, how, based on incoming information from internal and external world. Okay, limbic system. It controls various functions of the body, mainly interpreting emotional responses, storing memories, and regulating hormones. So it involves in sensory perception, motor function, and olfaction. And key words would be it sits in the, it's like a peach core, right? If we take all the pulp, all the soft structures, we'll find this kind of central brain, peel the peach. It will be responsible for emotion, behavior, memory, as well as survival, autonomic, and endocrine functions. So metaphor, same as I named before, it's emotional brain or limbic brain when we were talking about three brain theory last time. Key parts of the limbic system, and again, sometimes there are different structures and parts mentioned in literature, but thalamus normally is linked to limbic system. So thalamus is extremely important part of the brain that we need to remember about. It's the major sensory relay for connecting areas of the cerebral cortex that are involved in sensory perception and movement with other parts of the brain and spinal cord that also have a role in sensation and movement. Here, keywords would be sensory relay or hub. It will be responsible for arousal along with brainstem, for pain, motor and language, cognitive, associative functions, mood and motivation. So there are lots of there, but probably the key word would be sensory hub, or another word, I'm thinking of it now, pacemaker. And metaphor, it's more like executive department or phone operator, which connects signals or channels, which signals should come through, which signals should not come through, should be inhibited or timed for later. And we'll come back to thalamus again, so don't worry. One of the dysfunctions, I put dysfunction on this slide as well, because I think sometimes through dysfunction, you better understand function. So if you switch something off, you clearly understand what it was doing. Sometimes when it's not noticeable, when it's still, alive and functioning. So if you switch off thalamus, you may end up in coma, so almost vegetable state. So everything that makes you human and make you function as human will be mainly due to thalamus. As well, it's closely connected to cortex. So thalamus and cortex, that's what makes us. Hippocampus, another important hub for the limbic system, which is a memory indexer, sending memories out to appropriate part of the cerebral hemisphere for long-term storage and retrieving them when necessary. So memory is the key word, spatial navigation, learning, neuroplasticity. They are the same keywords for hippocampus. And metaphor, it could be flash drive or librarian or record keeper or a student who is absorbing all the information and sorting it out. Then last time I didn't mention it, but it will be extremely important when we will be talking about theta brainwaves. So I thought I should add it. Very often septum is mentioned along with hippocampus that we just talked about. So obviously it's also related to memory. Let me say a little bit more about this. So septum anatomically means partition, and it sits in the lower part of corpus callosum. If you remember corpus callosum, it's those fibers that connect left and right hemisphere. So obviously it's not just the end of it. There are more partitions or structures or fibers, membranes, and sitting underneath of corpus callosum, as this picture shows to the left. So you can see corpus callosum and straight underneath septum pellucidum. I'm not sure I'm even reading it correctly, but yes, it is connected with many other structures. Namely, it mediates connection between the cortex and subcortical limbic nuclei. And it has fibers that project to hypothalamus, hippocampus, amygdala, reticular formation, and olfactory cortical areas, suggesting a role in limbic regulation. Involved in a variety of functions, emotional, motivational, spatial, and it's densely interconnected again with hippocampus and plays critical role in learning and memory. I wouldn't go into more details here, but when it's disrupted, you'll have problems with your memory. So septal nuclei are essential in generating the theta rhythm of the hippocampus. Then another part, cingulate gyrus, it's a fold in the brain. As you can see, it sits again around the corpus callosum. And once again, it's one of these partitions or membranes, which is just the connector and connecting parts of the brain together. In particular, cingulate gyrus is about sensory input concerning emotions and regulation of aggressive behavior. And very often there will be mention of anterior part, so it's kind of frontal part, as we just learned, which is responsible for autonomic functions, heart rate, blood pressure, cognitive functions, like reward anticipation, decision-making, empathy, and emotion. This is very, very important part, which kind of is important switch. So if you lose this switch, you become aggressive. Keywords, I put corpus callosum cap, as it sits kind of on top of it. And then again, emotions. And when we talk about emotions, always create this link for behavior, because emotions, they just basically guide your behavior, saying, oh, I like it, I don't like it, right, wrong. So they help you to navigate and coordinate your behavior. Then autonomic motor functions. Again, whenever we talk about behavior, it's your action, right? It's your action in outside world, which will include your kind of psychological behavior. So psychological, I mean, component, and motor component, your movement, you have to go and do things. So emotions, behavior, and motor function, they all often come together. So it's predetermined mode. Again, how it functions will depend on, for example, how aggressive you are again. And metaphor for this is the decision maker, how you will act or respond. Then another important part, which is sitting inside, as you can see, we have to split. It sits in the lateral sulcus, so it's that groove, that sulcus that separates frontal, parietal, and temporal lobes. So if we open this, we'll see insular cortex. So we have cerebral cortex on top, and we have another cortex inside. So it's also responsible for sensory processing, auditory, olfactory, gustatory, visual, somatosensory, so many. So basically it regulates hunger, cold, pain. Then it's responsible for motor control. Key for us is it's responsible for self-awareness. So really, due to insula, we know what's happening inside of our body, like are we cold, are we hot, are we hungry, are we in pain, and emotion as well, so including social emotions, how we interact. So without this, without insula, we wouldn't be able to emotionally, empathically communicate to others. So obviously, it also affects perception, and its self-awareness is also related to mindfulness and overall connectivity. So it's integration hub of large-scale brain systems. And through all that I mentioned, obviously, since it gives you information of what's going on inside, on physical level, on emotional level, it also directs your behavior and motor control. As we discussed, all of these things will come in hand: emotion, behavior, and movement or motor control. So metaphor for this: observer, sense maker, and meeting place of need, demands, and resources supply, because it feels like it's the one which is trying to match and organize, identify what's going on, and then address the relevant resources of how to act in response. So I hope I explained this one. And I always leave my presentations and share them, so you could check them later, repeat, read slowly in more detail, because we are limited in time, but it's all very, very interesting. Again, brainstem, and we remember this is our animal reptilian brain, so that means we are talking about vital functions, survival functions. Brainstem motor and sensory neurons travel through the brainstem, allowing for the relay of signals between the brain and the spinal cord. So obviously, yes, this is the very top of the spinal cord. Relays information between the peripheral nerves and spinal cord to the upper parts of the brain. So it sends information back from organs and nerves back to the brain. Controls of life support and autonomic functions of the peripheral nervous system. This part, brainstem, it contains reticular activating system, which is extremely important because it's responsible for timing and transition between sleep and wakefulness, and also modulates the speed or synchronization of the EEG. So for us, it's important. Reticular activation system will send the messages inside the brain to a thalamus, and will, through thalamus, alert the cortex and say, hey, time to wake up, or time to sleep, and kind of shut down time. And it will also define the overall arousal tone, the background kind of tone of our nervous system. Keywords: stock-like portion of your brain, autonomic, because we are talking about breath, blood, and balance. I guess 3 key words, because without breathing and without a heart, we are dead. And awake, alert. And metaphors, again, animal brain, vital functions coordinator. As I said, blood oxygen balance. Without this, we are not functioning. And that's what makes brain alive, or makes really not brain, makes us alive. And then basal ganglia. I'm not sure we talked about it last time, but I want to emphasize and mention this part as well. Here is a great picture. As you can see, basal ganglia, it stands for a group of neurons. Sometimes they can be called like nuclei. And it's located deep within the cerebral hemispheres of the brain. And the main part of it is corpus striatum. It's the major group of it, quite big, you know, it's 10 cubic centimeters. Primarily, this is important because it is involved in movement, processing movement-related information. And of course, again, when we talk about movement, it will be related to emotions, motivations, and behavior. So when to act, when to move. And of course, that may involve cognitive functions as well, decision-making, when to act, when to move. So keywords for this one: movement, emotion, motivation, behavior. And the metaphor for this one would be go through a station within the motor loop. So inhibit, it means suppress, stop, block, or facilitate desired or unwanted actions. So in some ways, I thought maybe the word educator that, you know, guides and controls little children who can't control themselves yet. I mean, directing them how to behave. Maybe this could be another metaphor as well for basal ganglia. And amygdala, I'm sure even if you know very little about physiology, you might have heard about this element like little tiny nucleus, but which is so important for us because it receives sensory information from temporal parietal cortex through hippocampus and sends the result back to prefrontal cortex via thalamus. So the main function, of course, is collect all the information, temporal parietal. So we are scanning our sensory cortex, and we are scanning memory, referring that what we found with our memory to figure out, oh, is what I'm exposed to dangerous? Am I safe? So this is our alert system. And of course, main function is express fear and initiate associated with fear behavioral reactions. Obviously, it will be responsible for, let's go to keywords, arousal, fear, emotion, adrenaline, because hormones will be secreted, and memory. As we know, the more alert we are, or the more emotionally charged the event is, which means if something scares us, we may remember it really well. And metaphor, it's alert station. So feel free to drop your ideas or comments in chat as we go, because as I said, I think this is a very useful topic that probably we should repeat each year. And it's my first attempt to put it together. So hypothalamus, we talked about thalamus already. And thalamus is that sensory relay or hub or time pacer or phone operator, guiding, redirecting or blocking the signals from all sensory parts to cortex and back. This is a tiny part about the size of a pearl, and which directs endocrine and autonomic functions. It will be responsible for food and fluid intake, sleeping, metabolism, body temperature, and in general is responsible for what we know a state of physiological equilibrium, body homeostasis. Keywords would be hormones, right? Because that's when we think of endocrine system, that's what it does. Then homeostasis, sustaining all the bodily functions, supporting our survival, making sure we get enough food, we get enough water, our body temperature, we don't get too cold or too hot. So it's responsible for metabolism as well. And I just put the metaphor like housekeeper. here we are. I think, covered the third question from our checklist from previous webinar. And I also promise that we'll cover the third question in mind mirror related list. So what types of dysregulation might be addressed with the mind mirror, and what are the no-nos? I think it's very important, even if you know it, just to refresh. So here is the list of patterns of dysregulation that we discussed last time. There are 5 of them. And here because there is no information on this in relation to the mind mirror, that means I invite you to just logically cooperate with me and see what would apply or would not apply. So physiological arousal, by which we mean a dysregulation of arousal or excitability, could be from trauma, developmental, or the one that happened to you during your life story. And of course, general arousal, how alert you are, will affect how attentive you are, your general mood. Are you in low mood? Are you in good mood, just right mood, or are you in hyperactive mood? It will affect your tension, physical tension, muscle tension. So the more aroused, the more tensed you are, and your thinking. So I personally think that we do address physiological arousal as soon as we start addressing our beta, our fast brain waves, and we'll learn to relax, we'll learn to reduce the mind chatter through various exercises, through our imagination, through addressing, our senses more. Anna Weiss has lots of, and even Max Cade as well, they have autogenic exercises, which is a good starting point really for any training, for awakened mind training, and surprisingly or not, Alpha-Theta training, which is again the clinical analogy of awakened mind training to some extent, starts with training hands temperature. So it does help to calm down and reduce beta. So I bet by addressing beta directly, we address physiological arousal, plus by trying to stimulate alpha through our sensory perception. Yeah, these sensory exercises, visualizations. Indirectly, we also affect beta because alpha will take the blanket on itself, thus reducing beta. And then as we go deeper, sometimes we can dive in straight to theta. It will also kind of indirectly pull the blanket of beta. Then instabilities, internal loss of stability and control, or hyperexcitability, which can be genetic or due to brain injury. And examples of it could be headaches, mood swings, panic attacks, seizures. So this is clinical world again. And remember, in clinical world, we're working with clients, we're working with patients really who have serious problems. With the mind mirror, we normally address healthy people. And let me just mention again that healthy implies a range, it's a spectrum as well. So that's why we all can be healthy and normal, we can be introverted, extroverted, both is normal, as long as we are within the healthy range and we show kind of adaptive behavior which doesn't disturb us or bother or undermines our everyday function. So that means we are relatively healthy. But of course, we can tend to approximate to one end of the spectrum, to one border or to the other border. So instabilities, I guess we address this as well, because we always train left and right hemisphere. Plus, in clinical world, when the key location for instability would be temporal lobes, T3, T4, so this just above the ears. And that's approximately where we place mind mirror electrodes too. So these are very potent and powerful electrode locations, T3, T4 on temporal lobes. So that's why I can say that we do train instability, and especially when we go from awakened mind to evolved mind is perfectly balanced pattern. It's a circular pattern where basically you always will be, when you're looking at your training scores, you will see that left and right there will come by default, kind of, they always hemispherical balance enforced. Okay, so disinhibition. What do we mean by that? Loss of prefrontal self-control, agitation, stress, boredom, or due to sedatives, sedative medications, fatigue, low blood sugar, injury, obsessive compulsive disorder or attention disorder, immature or primitive actions and reactions, impulsivity, tics, emotional reactivity, etc. So disinhibition mainly comes as a function of underactivated prefrontal self-control. So it means prefrontal frontal cortex, that's what we are talking about. And we do not actually train beta directly to activate it and kind of, okay, beta in the front has to be stronger to control our emotions, to better direct our behavior. But I should say that indirectly we do probably address it, because we are heading towards the balance, right? Evolved mind eventually is a very, very balanced state. So we want to find the balance. And when you are searching the balance, as I said, indirectly, it will affect beta. So for example, if you have too much of it, like in obsessive compulsive, where you have compulsive behavior and you can't, it's hard for you to control yourself. So it's, I can't say we're not working in clinical world, but I guess it will reduce your obsessiveness, if I can say so, or impulsivity. So you naturally become calmer and less reactive when you switch from beta to lower frequencies of alpha and theta. Evolved mind is a very integrative state. So indirectly we'll do this as well. Localized dysfunction, specific dysfunction based on location, trauma, injury. Again, we do not work with the brain injuries with the mind mirror officially in our training, but here I advise you to watch the program with Suzanne Temple, one of our practitioners from Netherlands, who applied awakened mind training and combined work with the mind mirror, even some self-training programs with healing after brain injury, because she is a medium as well, and mediums and healers, they come hand in hand. So I highly recommend, if you're interested in having a look at that, watch her webinar where she shares her experience and good results. And the last 5 types of dysregulation, pattern of dysregulation, learned fears and habits. So implicit and explicit memories. So memories that, lie above conscious line of consciousness, memories that we're aware of, and memories that are suppressed somewhere in our subconscious that interfere with behavioral control and well-being. So this may happen due to early developmental trauma. And this is what we directly address in our personal transformation, in removing the blocks, in healing meditations, in awakened mind training. So this is all about exactly opening alpha bridge to be able to connect conscious and subconscious mind and to access what was suppressed, and then start removing or rising the suppressed memories, suppressed information through the line of consciousness to beta, discharging along the way through negative or very strong emotional content, and reintegrating basically traumatic memories, if necessary, into the right time and place in memory, because often We just have lots of emotional stuff that we carry, which pops up in everyday life, but doesn't really belong to exact situation in front of us. It just, as I mentioned, hiccup from some traumatic event that wasn't digested properly. So that's where we match the core of Alpha-Theta neurotherapy, where they work with traumas and addictions. So I think that Alpha-Theta training in general desires a separate webinar where we could talk maybe in more detail what they do in clinical world, what are the parallels, what's similar, what's different, and how it works. So here we come to cautions and contraindications for the mind mirror. Let's say that again, we are not working with pathologies, we are not doctors, unless you are a doctor and you know how to integrate, you figured out how to integrate mind mirror in your practice. So normally we should be very careful because when we work, we take people into deep meditations, and deep meditations may trigger seizures. So because they'll evoke the brain waves similar to seizures. So if there is anybody prone to epilepsy, we don't want to risk it. Okay, so that's why I highly recommend ask the person if ever there was any mentioning of epilepsy in his life story, medical history, or in medical history of his family. Then heart attack or stroke. So obviously we can touch something very, very sensitive. Very often if you go down into your subconscious, say for the first time, the person is non-meditator, and then all this suppressed stuff, all the skeletons jump out of the wardrobe, all the suppressed emotions flood back. And of course the heart rate will increase. So if the person has heart problems, no, let's not risk it. And again, it depends on general health. If someone is a long-term meditator and it's just kind of common for that person to swim and dive deep in subconscious and back in all kind of trances and alternative mind states, that's fine. Brain injury, again, you can, but with care, know what you deal with. Mental disability, that's definite no, because here you don't know what to expect unless you're a clinical psychologist or psychiatrist or psychotherapist and you are trained, so you can back up with your main, basically, profession qualification. Then substance addiction. So you have to remember that when we take medications, when we take, I don't know, alcohol, marijuana, all kinds of drugs, all this will affect our brain waves. We imply that coffee and cigarettes will be okay, but you still have to keep in mind that they will affect our brain waves, right? Because coffee will speed up the beta and speed up us. It depends, not beta, but maybe alpha as well, depends where we start, what's the starting point, but it will definitely contribute to overall arousal. And same with cigarettes and with other substances, they can open alpha, so you will not be able to differentiate whether this is the natural organic person's alpha or this is the alpha artificial triggered by these substances. So really we can't play with it all because they will interfere and it will be a waste of time. So when you see clients, you have to tell them to try to stay sober or maybe postpone the session if they had a busy night and party the day before, because otherwise the results wouldn't be so good. Then psychosis, depression, trauma, or dissociation. So again, when we go deep in meditation, we slow down, we go to lower frequencies of brain waves, and all of this may not be good in case of psychosis and depression. It may aggravate all of this. It may aggravate even trauma if the person is not ready, for example, to go that deep, or there is some painful material that we come across and may trigger like defensive mechanism of dissociation. So you don't want this happening when you'll see start with one person and then along the way end up with some other voices or personalities sitting inside the same mind and playing out to protect the vulnerable personality inside. So it's kind of, we are not prepared to deal with the theater. We deal with one person. Pregnancy, here I should comment that when I did the 3rd and 4th seminar with Judith, I was pregnant, heavily pregnant on my 9 month basically of pregnancy. But for me, it was okay because I am a long-term meditator. So even if I go deep, there would be hardly anything that would scare me to the extent that would harm or do something. So it really depends. So if you are not sure, you better not risk it. And below, first to the left, I put the post about mental status examination. I mean, if you are a psychologist, psychotherapist, or working in this doctor even, you will know what to look at. But if not, here I just highlight that I would recommend to ask about developmental problems, family problems, like epilepsy or mental health, brain injuries. Sometimes people don't even think of brain injuries, but it could have happened like anywhere in the playground, playing sports, during car accidents, or just times where they lost their consciousness. Then exposure to toxins is important as well, because it may affect the brain function in general. And then general health is critically important, because lack of sleep, stress, moods, emotions, current medications, addictions, bad habits, they all will play out. And pregnancy, obviously. Okay, so I hope now you are better equipped, and we can move on to the main topic of brainwaves origin and function, neuronal mechanisms and functional meanings. So that's to be precise. And before we start, I promise we'll be looking into what exactly we mean or we measure with EEG, with electroencephalograph. Last time, I think I mentioned, not last time, even 2 times during 12 amazing facts about neurotherapy, human brain in that program. And last time I spoke about pyramidal neurons. So they found in cerebral cortex, hippocampus, amygdala, and other parts of the brain, and they play a major role in generation of EEG. So excitation in pyramidal neurons, I mean, is the one passing information within the gray cells, and that's what we see. So the size and shape of pyramidal cells influence how they function. I thought that's interesting to know. Somatosensory pyramidal cells are large and isolated from other pyramidal cells, tending to operate in isolation. So these are the ones that pass the information from senses, right? Sensory receptors. Hippocampal pyramidal cells, which means memory, you remember, are smaller and tightly enmeshed with neighboring pyramidal cells, working something like a democratic committee. I guess they reflect the function of hippocampus, right? It's like a memory net. So whatever comes into hippocampus, it gets into a whole net of these pyramidal cells. At rest, pyramidal neurons have a negative internal space charge, with the extracellular space having a positive charge. So, which means there is a polarity, there is voltage, similar to how we have voltage in a battery, right? We have plus and minus. So we have minus on internal space and plus on external space. So this is called membrane potential. Pyramidal cells communicate with other cells. So that's how they pass information through junctions called synapses, using chemical messengers, neurotransmitters, which selectively bind to receptors on adjacent neurons and cause specific ion channels to open, allowing differently charged elements to flow across the cell membrane. When ion channels open, they allow positive ions into the cell, which carry an electric charge, This creates an electrical current. So here, in very simplified way, literally in a few sentences, I'm explaining that this polarity starts to change. So when neurotransmitters bind, with time, this polarity starts to change, and this creates flow of electrical current. As one end of the cell is relatively more positive than the opposite end, this relative difference is called an equivalent current dipole. The equivalent current dipole of a cell creates a small electromagnetic field, like the field of a magnet. When numerous neurons simultaneously generate dipoles, the local field potential becomes highly organized or synchronous. Here are two more things. So battery, and here I show how these yellow dots you can see below represent neurons generating dipoles. It's not below, it's in this cube, spinning cube. This produces sufficiently large voltages that can be detected at the surface of the head, what we measure with EEG. So important part there is that this process, this voltage, this should be long-lasting for us to pick up. It should occur over a large area of the membrane, again, for us to be able to pick it up, and occur almost simultaneously in thousands of pyramidal cells. I wouldn't go into more detail, but there are phases of how it travels, and there is a threshold, or there are a couple of thresholds, the turning points where this depolarization goes to maximum speed, and then when it stops and goes back and return the cell back to its normal usual state. And sometimes when it returns back, it even hyperpolarizes, so it's exhausted, so the cell can't go through new excitation anymore because it's just exhausted. It needs state of rest, to be in a state of rest, and that's when we are in deep sleep, apparently. I will pass this slide, not to overload you, but yeah, here are these thresholds. So normally -70, this is the normal charge, the negative charge, and then when it reaches -55, more channels open, letting positive ions in, and you look what happens. So it rapidly reaches a very positive charge, and then after that there is turning point where it drops down. So 30 plus 30 microvolts, it goes back, and that's repolarization, and then in the end there will be hyperpolarization. If you like to see in a more detailed wave generation, so these are like bursts that we pick. So membrane potential, these are these bursts. This is postsynaptic potential. So this is the change after neurotransmitters binding, change triggered by neurotransmitters binding, this potential change. And that's how kind of these bursts turn into a wave. Let's just leave it there and talk about more interesting stuff, that a single cubic millimeter of cortex, which is the spatial resolution of current MRI technology, contains an astounding area of energy regulating equipment: 13,000 pyramidal neurons, 24,000 glial cells, 100 billion synapses, and 100 meters of axons. As for EEG, although electrical activity from as few as 10,000 pyramidal cells acting synchronously may be detectable at the scalp, each electrode itself spans an area containing 5 million pyramidal neurons or more beneath it. Those who watched my program about amazing facts about neurotherapy and the brain know already this. And I made comparison to a big city. Just think, say, population of Sydney will be probably around 5 million people. And imagine these 5 million people working in synchrony. Imagine the level of organization. That's incredible. And then another thing that, again, those who watch that program would know. So it's about the fact that what we see as different frequency bands, we receive these frequencies by splitting, so to say, the raw EEG wave into components. So to be precise and to be correct, we should be talking about frequency components. And the Fourier transform is a mathematical function that can be used to find the base frequencies that a wave is made of. Here on the left, there is a picture, and you can see raw EEG on top. And this is how raw EEG looks like. And then through this mathematical, through mathematical formula, we derive delta. And you can see delta is the slowest wave. It's kind of the major contour of it. And then theta is slightly faster, what sits on top. And then alpha, which is even faster. So the faster the wave, the more information it carries, similar like in the radiology. And then beta, even more, very dense, and gamma, super dense. So you can see that actually in raw EEG, it's like this. And to better understand, you can say, compare it with playing a chord, musical chord on a piano. When played, the sounds of the notes of the chord mix together and form a sound wave. This works because each of the different notes waves interfere with each other by adding together or cancelling out at different points in the wave. A Fourier transform takes this complex wave and is able to find the frequencies that made it, meaning it can find the notes that a chord is made from. Fourier transforms are important because many signals make more sense than when their frequencies are separated. So in a way, it's a bit artificial procedure, but it helps us to make sense from what's going on. It's similar to how we dissect different structures or subsystems in the brain just to understand how they function and so how they interact with each other. Here is a light, light wave as well, split into lights, different color spectrum as an example. So just a reminder that note that when we stick mind mirror electrodes, we always use the same location. So these are always temporal lobes, left and right, and these are always occipital lobes, left and right. In clinical world, there will be, the location will be very important. I mean, when we are talking what is normal, what is abnormal, and to what extent. So EEG rhythms origin, and that's what we will be talking further on. Let me remind you that with the mind mirror, we associate brain waves with different levels of consciousness. And what we train navigation through different levels of consciousness using brain waves as a map. So beta would be conscious mind, alpha would be the bridge between conscious mind and subconscious mind. Subconscious mind will be represented by theta, and unconscious mind by delta. And the combination, of course, of those, because they always act together, will define the state we are in, and mainly the dominant frequencies will dictate what's going on. Dominant frequencies, again, I often say, this is like who is playing the leading party in this symphony, whose time is to solo or dominate. Here is the dynamics, and once again, looking at brainwaves of the desired states. So we start with ordinary pattern, and desired states that we train are awakened mind pattern, this one, and evolved mind pattern. You can see that with the mind mirror training, we actually train in hemispheric balance and alpha-theta. I mentioned that already before because we want balance in our brain, and we want alpha being open and access to our subconscious. We want to use maximum resources, so to say, to be able to reach any corner, any frequency, or make use of any frequency in the brain. And basically without alpha open, this is impossible. This is the first step, alpha bridge, may be associated more with peak performance training. And then we go deeper. As you can see, we open more bottlenecks and open theta, so which will be closer to alpha-theta neurofeedback, where we learn with, where we deal with learned habits and behaviors, and where we start reprogramming ourselves, addressing the suppressed material, bringing it to surface, reintegrating it, discharging emotional stuff. So here, a reminder, we are starting with alpha. Really, alpha itself can deserve a separate webinar. I've been talking already for almost an hour just to get to this point. So as I agreed that I'll go as much as possible today, maybe another hour, and stop there and do another program to continue, because all of this is extremely interesting and important. So alpha, we look at the range of frequencies from 8 to 14 hertz. Again, please pay attention. Sometimes these ranges could be different from, one textbook to another, from, one teaching to another. So alpha, we call it gateway to subconscious. We say this is relaxed sensory awareness, activated and felt as the mind shifts from the external to the internal world. And it's the state will be daydreaming, reverie, visualization, imagination. So to add, alpha is a sign of an altered state. So we just seen how ordinary mind looks like. It's when alpha is a bottleneck and beta is dominant. So beta dominant means only conscious mind is dominant. That's it. There is no other world, no other reality, all other doors closed. So as soon as we open alpha, this is beginning of the altered state. So it's beginning of meditation. And we can go further, we can go deeper, and it can allow for better, more optimal mind use and deep reprogramming. It's entrance to deeper states as well. So we see always alpha bands in green. So what do we need to know about alpha in kind of science, in clinical world, in history? So in general, alpha are called alpha because they were the very first waves ever discovered, and by the basically father of EEG, Hans Berger, in 1929, because alpha is a dominant posterior rhythm. So in the back of the head, this is a dominant rhythm in healthy adults. So obviously, even not having the super complex technology, he still managed to pick this rhythm, and he called it waves of the first order, and that's why it's alpha. What else? These are rhythmical dominant waves. Again, they will stand out because they are more sinusoidal and organized. 10.5 hertz dominant frequency for alpha would be the norm. So alpha would be dominating in a healthy adult, but it will change with age, and we'll talk about it later. So in general, this is idling rhythm of different sensory areas, somatosensory stimuli restricted, blocked on eye opening and mental effort. So when we close our eyes, some people are able to keep alpha open with eyes open, and there could be good reasons for that and bad reasons for that. And again, we'll talk about it later. But most of normal people will have alpha increased on eyes closed. So that's what we clearly can see when we ask the client to close eyes. It should increase like 50%. And then when the eyes are opened back, or we ask to think, the beta kicks in, the alpha will be blocked. So alpha and beta, in this sense, they work like different, I don't know, sides of the coin. It's either or. They sit together on our mind mirror pattern, and obviously they are closely interrelated, interconnected. When one is open, it pulls the blanket from the other. Okay, locations. Where can we see alpha on the skull, on the brain? Normal locations. So, of course, the dominant one, as I mentioned, it's occipital, it's the back of the head, and it's connected to our vision. Then parietal, it's just above that. It's our main sensory processing lobe. And then central, it's the very center of the head, sitting on central sulcus. So all these locations, they're different in topography. They are slightly different in frequency, and they are different in sensitivity to different tasks. And we'll talk about it in more detail. And of course, state will be relaxation associated with alpha. And the origin in one word would be thalamic, cortical, thalamic. And again, I'll explain it more. It's just a summary slide, introduction slide. Function of alpha, adequate and active and adequate inhibition of irrelevant sensory pathways, by which we mean irrelevant information. Let's have a look at the next slide, so this is the role of thalamus in brainwaves generation. I mentioned it again, but I will have to repeat it a few times because it's the core. The core not only for alpha, but also for theta, beta, and delta. As we know already by now, the thalamus receives sensory information from sensory pathways and projects this information to the neocortex. The thalamus acts as a gatekeeper, coordinating the timing and distribution of information to the rest of the cortex. So here two things are important. So it's not only the information flow, but it's also the timing of information flow. It means when the gate to open, when to open the gate, when to close the gate. So that's why it can be also called the pacemaker. Each thalamic nuclei projects to specific portions of the cortex, which in turn project back to the same thalamic nuclei, which forms a feedback loop. So here on the left, you can see the picture, and you can see these pathways. You see these fine, colorful lines going to the back, to the side, to the front. So all of this basically will be these thalamic projections or connections with the cortex. It will receive the information from senses and then send it to the cortex and then receive the information back. Here is another loop. It shows thalamocortical nuclei will be talking at the same time to our reticular. Remember, reticular activating system and brainstem, which dictates the overall arousal tone for the body. So it will communicate to the reticular formation, and it will communicate to cortex, and thus they all will get the messages. The cortex will get the message of when to be alert or when to relax. So alpha, thalamic cells have intrinsic ion channels that allow these cells to oscillate at approximately 10 Hertz, excitatory to cortex activity when at equilibrium. So really think of alpha as, I think of it as a kind of beginning of coordinates, as in some way, I won't show it today, but they say that when they measure blood, due to modern technologies, blood in the brain, blood flows to where the activity happens, right, where the action happens, because blood is the major resource of oxygen supply to all these information processes, right, and chemical supply. So obviously, when you see where the blood is, it will tell you where the main action is happening. So when alpha is in its resting state with eyes closed, we can see the blood covering the areas of default mode network. You may not know much about networks, but default mode, I think just the title of it stands for itself. Like in any computer, in any electric device, there are default settings. So actually, in some way, this is my understanding again, and I always comment when I introduce my interpretation, my metaphor. When we close our eyes and go into this idling mode, relaxed mode, opening alpha, we access this default mode state. And it's very important for basically helping us to sustain equilibrium, helping us to return this equilibrium and be able to self-regulate, for self-regulation. And we have to remember that alpha is kind of idling, starting rhythm or beginning of the coordinates. But then thalamic oscillatory patterns are heavily influenced by inhibitory activity in reticular neurons, which can hyperpolarize and slow thalamic oscillations to 6 Hz. So again, what we read here, through reticular formation and through other mechanisms, what happens, these thalamic oscillations, they can slow down, and thus they slow down to 6 Hz, which means we will see them as theta, because 6 Hz will fall in theta range. Then beta cortical neurons respond specifically to distinct thalamic frequency inputs and relay their activity back to the thalamus, which forms a positive feedback loop. When both are inhibited, frequencies frequencies up to 20 Hz can be generated. So again, if there is another story, inhibition will imply activation, arousal. That means we go up, we go faster to 20 Hz, and this is beta range. So same mechanism, just different pacing. Okay, that's why here to the right, I showed this picture where we actually just regulate arousal. We can go here, we can go back. It's like a pacer for the brain, this thalamocortical interaction. It's like a pacer. Delta, thalamic neurons can enter a low threshold burst mode when deeply hyperpolarized, resulting in thalamic delta activity, as is during sleep. So many unknown words maybe. Burst mode, deeply hypolarized. As I said, hypolarized, it means after they go through the cycle of basically excitation, depolarization, they're activated, in simple words, and then are deactivated, they go back to normal, and then they drop below normal, and they just can't excitate anymore. So this is hyperpolarization, this is period of rest, and this is delta. So I hope this was a great overview to give you an idea. And here, once, by the way, I'll talk about this picture again later, but you can see how this burst can be converted into faster waves that we see, beta, alpha, and then slower theta. And the more depolarized means the more excited. So we go from slow, theta, alpha, beta. And another thing about alpha, we'll continue about alpha since this is the topic. So here to the left, you can see again a nice picture of thalamic radiations going to top, front, and back to all the sides, major radiations. And then regarding alpha, main function. So alpha is, as I said, beginning of coordinates, the starting point, the default access to default mode. So alpha is thus key in the regulation of arousal, organization of information, orientation, time, and goal-directed behavior. That is, it underpins the temporal organization of knowledge-based consciousness. So alpha decides what to let in and when. Thalamic nucleus control internal attentional searchlight. So it's like a torch that shines the light and decides where attention will go, metaphorically, of course. And another interesting thing, during consciousness, a continuous dynamic interplay between alpha and other frequencies, as defined by their harmonics and Goldman relationships, exists that facilitates or prevents the concurrent activation of neuronal systems. Here below, I wouldn't go into detail. You can even calculate all other frequencies starting from alpha. Slower frequencies can be determined by dividing alpha peak by 2, blah, 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 blah. So basically alpha, the border of the ranges can be determined by finding golden mean frequencies relative to alpha. So again, alpha dominates, alpha rules, it sits in the center, and it's like tuning fork maybe for all other frequencies. Again, starting point and tuning fork for other frequencies. That's why it's important to make sure alpha is dominant, that's healthy, that's normal. Here we go in more detail, talking about alpha. So attention, the inhibitory nature of alpha and observation of its desynchronization means activation during cognitive tasks, suggests it underpins neuronal aspects of attention. Attention is typically a top-down process acting as a spotlight, as I said, or a torch, interface or buffer with the external world. So perception filter. This is closely tied to perceptual processes and predictions about stimulus relevance and the type of information a stimulus conveys. In this respect, alpha represents anticipatory and temporal attention, acting as an attentional buffer. Memory retrieving. So in some way, alpha is scanning the background memory for the relevance. Is it relevant? Is it not? The predictive component of alpha requires the integration of semantic and episodic memories, reflecting how well encoded and semantically coherent the information retrieved is. So alpha is participating in memory retrieving and to some extent in information organization, which means memory consolidation as well, how it packs information, because if it highlights something as important, obviously it will be easier retrieved and better organized. Orientation in space-time. Top-down attention mediates the suppression and selection of relevant sensory, semantic, and episodic information by alpha activity, which facilitates conscious orientation in time, space, and context. So again, alpha picks what's relevant, and what's relevant, how we decide what's relevant. We'll pick the signals, what coming in signal, and we compare with the context. So there is some orientation and consciousness there, right? To make a decision whether this is relevant or not, and to orientate us in space. And then arousal performance. Alpha is thus key in the regulation of arousal, organization of information, orientation in time, and goal-directed behavior. It underpins the temporal organizations of knowledge-based consciousness, just the same thing that I mentioned on the previous slide. So basically, by cutting off what is irrelevant, it guides and directs us towards, behavior, optimal behavior. So keywords here to help us memorize alpha function would be attention, suppression, inhibition, selection. So basically, one word may be easier for us to remember: selection, because it's more common. Processing and organization of information, obviously. Orientation in time, it's focus by cutting off what is irrelevant. Goal-directed behavior, focus on what is relevant, directing towards the goal. And memory retrieval. So a few things, maybe attention, memory, focus, goal-directed behavior, understanding of the context. If you want simpler words, that's how we would put it. Then what types of alpha should we differentiate? And we'll start with alpha that we well know, right? This is posterior. Posterior, again, I mentioned in the beginning of today's presentation, it's in the back. It means in the back. And posterior rhythm may be occipital. It means on occipital lobe, that's where we stick electrodes in the back of the head. It's O1, O2. Or parietal, on parietal lobe, just above, slightly higher, which is an occipital stands for vision, parietal for sensory processing, it could be P3, P4, and sometimes alpha can show temporally, because obviously it will resonate, and in some time, sometimes it can be dysfunction, sometimes it can be resonant, sometimes dysfunction. So dominant rhythm in healthy adult, once again, the occipital, the back of the head or posterior, not necessarily occipital, can be occipital parietal. So it's age dependent and reaches 8 Hertz by 3 years old. Before that, alpha is just forming. And again, we'll talk about it on the next slide. So what happens, alpha is blocked on eye opening because it's resting. It means when our senses, and especially vision, 80% of our perception of the world is through vision. So as soon as we close the eyes, it opens. If we open eyes, it's blocked. And 90% of people will show that, but not everybody. Remember that too. And when alpha peak frequency will show, basically, I can't say for sure, but to some theories, it is associated with cognitive function. And the higher the dominant alpha frequency, the sharper the brain. But this is still arguable, depending on the source that you read. But definitely when alpha peak frequency is dropping, it is a sign of cognitive decline or a cortical degeneracy. So it may drop with age. Blood oxygenation level dependent, BOLD, it's in simple words, this is where blood goes when alpha functions. So when alpha is at rest, idling rhythm, as I said, it's in default mode network. So here are the pictures, let's see to help you memorize what I just said. Posterior rhythm, here I took the picture from previous presentation. So here, parietal, occipital, sometimes it can go here as well to temporal. And then on the chart with locations, you can see it's there. Here is the picture of how it's activated. You can see posterior alpha, busy in the back of the head, 10 Hertz. And then you can see how EEG behaves. So you can see eyes closed wave, so nice sinusoidal wave amplitude. As soon as eyes open, alpha is desynchronized. You can see it disappears. And then eyes closed, alpha appears again. And regarding blood, we can see as soon as eyes open, blood flows to the back of the head. So it's kind of less amplitude, but more blood, okay? And then same story, basically showing where we can see the waves, how they look like, posterior alpha rhythms, back of the head, and this peak frequency around 10 Hertz. So this one might be interesting. Again, those who watched the previous program, 12 Amazing Facts, they would know this. This is about age dynamics. During eyes closed baseline test, the rest, the theta rhythm, 4 to 8 Hertz, dominates the spectral energies of a child's brain, whereas the alpha rhythm, 8 to 12 Hertz, dominates the adult brain. So what is normal for children may indicate a problem for adults. Slow dominant frequency may indicate attention disorder, brain injury, or dementia. And here is a picture showing this fact. So we can see children, and you can see blue is less, red means more. So we see red in the back of the head in theta range. And here we can see adults, and red will be in the back in alpha range. And we can see how alpha develops. So newborn, not present, infant 4 to 6 Hertz, toddler 5 to 8 Hertz. And I just mentioned before that it reaches 8 Hertz by the age of 3. Then preschooler, it's 7 to 8, and preteen 9 to 10. So basically when we become teenagers, we have full kind of abstract thinking ability. due to fully developed alpha. So the brain is maturing, and as it's maturing, it speeds up, obviously. So we know that babies, they sleep in delta a lot, right? Then theta comes in until preschool age. By teen age, we mature, our brain matures. And then the opposite happens when we go old, become old. So you can see here that alpha peak frequency at 0.1, alpha amplitude, as well as peak frequency may drop. What happens, alpha is associated with cognitive and memory performance. Upper alpha power increases, but theta power decreases from early childhood to adulthood, whereas the opposite holds true for the late part of the lifespan. Yeah, I said like coming out of sleep and falling back to sleep, but not quite. Alpha power is lowered and theta power enhanced in subjects with a variety of different neurological disorders with aging, where slowing alpha peak frequency may indicate onset of dementia. And good news, it can be offset with neurotherapy. And here you can see the age chart, and you can see healthy control, the black line, and red is those with dementia. And you can see alpha peak frequency sharp decline somewhere after the age of 40 for those in dementia group. So yeah, you are losing your brain. Here, those of you who watched the previous programs, they know this already. Biomarkers, of course, for us working with the mind mirror, we want to know more what else alpha can tell us, since it's such important, especially posterior alpha. So the closest book I could find is Paul Swingle's book. I will show you it in the list of books that I recommend in the end of this presentation. He's measuring left location only, 0.1. And it comes from the legacy of Peniston-Kulkovsky alpha-theta protocol. So he pointed the following biomarkers. Alpha response. This is what we mean by alpha opening when eyes are closed. So if you see that your client closes eyes and alpha is less than 50%, or we mean significantly less, ask about traumatic stress, poor retention of information. So basically alpha is, you can open alpha when you can relax, when you let go of your conscious guard. And if you can't let go of your guard because you feel insecure, because you were traumatized and you're full of anxiety, and often when you're anxious, you also cannot retain information. So you can see now how it all falls into place. And then I marked in red another biomarker, which is brain efficiency that I talked about. Alpha peak frequency should be above 9.5. So if peak frequency, for us, we see it as the biggest band, right? Green band on the mind mirror display. If it's lower than 9.5, ask about mental sluggishness. So it means the brain is a bit slow, and there could be many reasons for that. So it's our job to research then and maybe train it, help to train it a bit up. Here, I again introduced this in previous program, that modern EEG is digital, which means we can easily quantify and do statistical calculations, generalizations, and create databases with what is normal, what is abnormal for this or that brainwave. One of the leaders in this field of QEEG is Jay Gunkelman, who with his colleagues managed to create a list of phenotypes. Okay, what are phenotypes? It's how to say characteristic EEG patterns for this or that abnormality. So he managed throughout all of his life experience classify all these EEG patterns, characters into groups. EEG phenotypes are intermediate steps between genetics and behaviors, involving expression of both genetic and environmental factors. These biomarkers that can guide personalized medication and help predict the potential effect of antidepressant, stimulant, or neurofeedback itself. And other cases, it can be useful, like professional suitability tests. For example, you can't have a pilot with a seizure-like abnormal EEG because it's simply dangerous for the pilot and for everybody else. So in the previous program, I said that many doctors up to these days look at symptoms and choose symptoms as a guidance for medication. And it's more like trial and error, and it's more depending on how patient presents the problem. And it's just linked to behavior, and it's very subjective, so to say, because it will be subjective how the patient presents it, it's subjective how the doctor is able to, receive it and interpret it. But with EEG and QEEG phenotypes, it can be predictable. It's like a signature for certain mental illnesses that can at least guide you with not maybe 100% precision, but certain signatures are there and can be identified. So we are interested in QEEG phenotypes or signatures for alpha. So if you see slow alpha peak frequency, slow frontal alpha, it is more common for ADHD. This is the top chart, and this is the major differences with control. So slow alpha is common for attention disorders. And then for the group of depressed, there will be not enough of frontal alpha and too much of central alpha for depressed. So not enough alpha in the front would lead to depression or may indicate depression. A few more phenotypes that I pointed out. So this one is said that in 10% of population, there is no alpha in the resting state. So you may think there is trauma or something, we don't know, but this can be simply heritable. If you remember, I said 90% of people will open alpha on eyes closing, but 10% of population may not do it for the simple reason that this is their kind of characteristic trait, even genetically transmitted. Could be a deficiency in inhibitory transmission, called low voltage alpha or low voltage fast EEG. So we're interested in alpha, and we're interested to know how we can understand this. So we may find that it doesn't mean that these people cannot open alpha at all. They can, but they can't do it naturally. Their organic normal function is disrupted. So there is not enough inhibition. And the consequence of that could be, or even not the consequences, the cause of it could be as well alcoholism. Often people with this pattern, with this phenotype, they show increased risk for substance abuse. So it's common for alcoholics. And this is also common for anxiety-prone individuals. This could be also a metabolic issue. So metabolic support should be considered. Yeah, basically we should be training, still helping them try to open alpha naturally and starting with the most dominant alpha rhythm posteriorly. So yeah, and that's why you can say that such people, if they are prone to addictions, alcohol and marijuana will be a type of self-medication for them just to relax, because apparently in their system it's just hardly working. Then there could be the opposite case when you have persistent eyes open alpha. So as I said, we consider it's good, but it's not always good because it's another problem. It means its alpha is diffused, and it is common for under arousal. In this case, we want to train, enhance faster alpha frequencies and suppressing slow. When it goes slow, it's the opposite. As you know, you get more depressed, basically. Then there is faster alpha. Alpha is highly inherited and dependent on genetics, hormonal changes, cortisol levels, simply motivation. So usually when you see faster alpha, we already know that it can be also a thing related to anxiety disorders, including PTSD or post-traumatic syndrome disorder. I wouldn't go too much into detail here. Then there is a difference in occipital and parietal alpha, what they are doing, though they're both posterior. What happens on eyes opening to visual stimulation, we can see that occipital alpha is suppressed, desynchronized, while parietal pathways will be synchronized, which is the opposite. So basically, when we open our eyes, it disturbs the resting state of background alpha, but it calms parietal alpha. Another alpha, which would be very interesting for you to know, it's central alpha. As you can see here, for example, it's like two eyes, like a monkey face, and it sits on very top of your head. So it sits on sensory central strip, sensory motor rhythm. If you remember the previous program, it's the strip around central sulcus, and there is somatosensory and motor. So it sits there, and sometimes this rhythm is called mu rhythm due to Greek letter mu, because the waves resemble mu-like shape. And again, here on the head, I showed the C3, CZ, C4, so these are the locations. This one is indirect indicator of function of the mirror neuron system used in studies of psychiatric patients. So in general, mu appears, this type of wave appears when individuals are sitting still and not planning, imagining, or visualizing motor activity or watching movement of others. The rhythm disappears when an individual moves, visualizes, plans movement, or observes movement in others. And the best way I could describe it is, we know posterior or occipital alpha, the one that we just talked about, the alpha in the back of the head, as the idling visual rhythm, right? So if that one referred to idling visual, to this one will be idling motor rhythm. So it means if we are not moving or we are not planning any movement, because our brain works in a way that even if we're imagining something, we can we may activate, reduce background alpha. Background alpha may drop. Similar happens with this motor alpha, let's put it this way. That one was visual in the back, and this one is motor in the center because it sends over sensory motor strip. And here I made a nice insert about mirror neurons because it's again a very popular topic today, so I thought it would be interesting for you to know more. So mirror neurons are unable to differentiate between the self and the other, which is why they respond to others' movement, just like they respond to our own thoughts about moving. Mirror neurons form a network in the brain taking high-order visual information, which is then interpreted in the frontal lobe before being sent to the sensory motor areas to activate neurons as if we were taking that action. The association of mu with the ability to imitate was first observed in monkeys, when the rhythm desynchronized, when the monkeys were observing actions of others. So it means this rhythm is involved. This activity of motor cells to the actions of others is important in our ability to imitate actions, which is important in the development of motor skills. It's important on many ways because we not only are able to empathize and have an idea of mental state of others, it's important for social interaction. It's important for learning because we may learn faster if we can replay in our mind when we see somebody else doing it. The abstraction of this behavior could be important in inferring the goals, beliefs, or moral intentions of others. So it's really on the bigger level, just the so to say, the foundation for us to be able to understand others. And interestingly, in a study of sex-based differences, the data showed enhanced empathic ability in females relative to males. So obviously, it's likely that females have more active mirror neurons. Also, personal identification with others is impaired in certain mental disorders like autistic spectrum disorder, schizophrenia. For autistic children, it's difficult to relate to others. They cannot follow what others are doing, what others are feeling. So it's an interesting topic in itself. And again, here is comparison of posterior or occipital or visual alpha versus the central, in other words, relentic alpha. And you can see here, I marked it in red, that background alpha is suppressed in response to opening eyes. And this central alpha or neurorhythm is suppressed in response to motor action. So you can see now that this is more like sensory visual and this is more motor alpha. And the last type of alpha is auditory alpha. It's rare, a bit slower, it's 6.5 to 10 hertz, and it desynchronizes or drops in response to auditory simulation, especially to meaningful sounds such as spoken words. Degree of desynchronization is affected by how easy the auditory cue is to understand. For example, foreign accents, gender, speech rate, tone echoes, multiple speakers, and artificial degradation of sound quality all influence desynchronization. The tau rhythm is often difficult to detect, and event-related potential analysis, which will be covered later, is typically required. It is not to be mistaken for slowed alpha in the temporal lobes, which is an abnormal alpha rhythm. And here I just showed you where it's located, auditory. You see it sits on temporal lobe. Here is auditory center. And here is just normal alpha band. And then this is tau alpha band. And here is the period of time where there was emotional sound. And you can see that normal alpha didn't respond. And you can see that left and right tau bands, they did respond to the sound. So it's quite rare and no particular attention really should be spent on this one. The other one, I put it as type 4, but you have to keep in mind it actually doesn't exist. It's a type of abnormality. So if we ever see alpha frontally, I mean, we have to remember alpha is mainly responsible for sensory and motor function, right? We associate it with thalamus, sensory and motor. And when we think of sensory and motor, it sits here, motor and sensory down there. So everything in the front will be more related to executive function, to decision making and planning and all other stuff. So whenever alpha slips into the front, rarer this could be in temporal lobes, it's a dysfunction. Posterior central obviously is the norm. So frontal alpha asymmetry is a biomarker of depression. Involvement of a bit of frontal cortex in the motion makes it trait-like asymmetry of anterior cortical activity, thus can predict effective motivational behavior. So obviously, if alpha slips into the front and there is asymmetry, of course, obviously that will affect the behavior and affect our moods and emotions. Traditionally, left prefrontal lobe is considered to be biased to positive stimuli and right prefrontal lobe to negative. And in this case, since alpha is working kind of back to front in a way, as we know, it's less in amplitude but more in blood. So the larger frontal alpha activity in the left will indicate depression. And usually the larger front activity right may indicate anxiety and emotional problems. So again, you can visit Paul Swingle for more biomarker guidance if you want to know more. And temporal alpha phenotype is usually a sign of degradation, metabolic issue, language problems, cardiovascular problems, mood issues, in the brain. That's something that I have, which apparently is, I don't know, consequent genetically passed. So it's cardiovascular, could be also heritage of trauma, mine or inherited trauma, epigenetic trauma. So here we came to alpha summary checklist. I want you to unmute and help me answer this question. And as I promised in the beginning, if we go slow, we'll just have another program to cover the rest of the brainwaves, because they all deserve attention. They all are important. And I just don't want to throw all of that information at once at you. And at the same time, believe it's very important to know it. Who was listening attentively and can tell me what is the origin of alpha rhythm?
I agree with the one who said thalamus.
Yes, thalamus, that's right. To be more accurate, we are talking about thalamus communicating with cortex, right? And the rest of the brain with reticular formation and the cortex, because they all will set the pace. Where, or maybe alpha is maybe the timekeeper, the clock. Where, in which locations can we see alpha? Use any words that are easier for you to use. You can use like posterior, or you can name the lobes. It's up to you.
Occipital.
Mm-hmm.
Parietal.
Correct.
Posterior.
Yes, occipital and parietal will be posterior, right? And this will be the dominant alpha rhythm. And this will be blocked on visual sensory stimuli, right? Yes. And where else can we see alpha? I mean, without frontal. The mind mirror, in general, I'm saying, where else we can find alpha?
Frontal as well.
Frontal, yes, and there it will indicate abnormality, right? Because it's not supposed to be there. Alpha is not the one responsible for thinking. Alpha is responsible for sensing, and alpha is also responsible for movement, for motor function. So one more allocation we forgot. Where does motor function sit? Do you remember? Sensory motor strip. It sits right above the center, right? Yeah. That's why the sensory motor strip is, as I mentioned last time, I think, it's one of the major crossroads in the head, because its senses come together with the motor function. So it's kind of integration of all input and turning it into output. You remember last lecture, last webinar. So that means this is such an important kind of pathway and crossroad, and it's commonly trained in peak performance, because it will affect so many neural pathways and create the necessary inhibition, or kind of to act efficiently. I promised to talk more about peak performance, but again, I realized I need separate program for Alpha-Theta and separate program for peak performance for us to understand. But in short, I'll say that to be able to function adequately and timely, we need to be able to still and cut off everything unnecessary, cut off the noise, block all irrelevant information, and focus on what is relevant, right? Because we learn how many units, how many neurons are activated at once, and energetically, like from the energy electricity point of view, it's a very consuming event. So we really, our brain is always functioning in energy consuming mode. So with least effort. So that's why we have to be still until the action is needed, right? Otherwise, what if I need to act and I'm exhausted? There is no energy there. The kind of the energy is used elsewhere, is wasted. So what is main alpha function? How you can describe in your words, keyword, 2 words, 1 sentence?
Motion.
But main, I wouldn't start with motion. I would start with, remember keywords. I was telling keywords. It's adequate and active inhibition of irrelevant information, right? That's generic, kind of generic sentence. But when we were speaking in particular, alpha will stand for attention, right?
Focus.
Cognition, level of cognition.
Yes, level of cognition, because attention will define our level of cognition, right? If we are attentive, yes. And what else? Arousal, alertness, because it will define
space-time orientation.
Yes, space-time orientation, correct, because it will help us to make sense out of the context, right? Highlight, oh, this is important, and this is the context, and that's where I have to go, right? That's the torch. That's the spotlight that kind of shines the light, plus searches, scans background memory to kind of understand the context and relevance, you know, and the previous experience. So that's why it's memory retrieval as well, because without this, we can't. Maybe next time I should put it into a formula or algorithm, how stimuli comes in, and then we have to take it, and it's sensory input, right? Input comes in, and we have to compare it with what we already have in our data bank, in our memory bank. So we scan for relevance to recognize and interpret the context and see what's next, what we have to do. Attention, arousal, memory, cognitive function, focus, goal-oriented behavior, all of this will fall into category of alpha function. What are the resulting state correlates or implications of alpha function? So what could we say? It's what state? Let's just put it this way. What are the keywords you can associate alpha function and state with?
Relaxation.
Balance between arousal and lethargy, something like that, a balanced state.
A balanced state. I would say it's more like alpha is relaxed state, readiness for action state. Do you understand? We call it also, how we call it, relaxed focus. So relaxed focus or readiness for action, right? Because if you are too busy doing this, doing that, you'll miss something. But then if you are just still and very attentive and alert, you're ready to pick the signal, right? And become ready for action. That's part of also peak performance. So I'm trying from different sides and different words just to shape it up, because I got a bit disappointed in how it's presented everywhere, but I try to get the essence of it. You know, when you understand the mechanism, when you understand the essence, you can put it into metaphors and play with it, and it will kind of sit firmly in your mind. So, but really you understand why alpha is so important and why any peak performance, and why we start with our awakened mind training with training alpha. And what alpha biomarkers do you know? Think what, like at least those that we can see with the mind mirror.
Increased alpha activity.
Increased alpha activity. You mean in
awakened mind pattern?
Yes, but biomarker, by this I mean some abnormality or underlying problem, right?
Oh,
so biomarker, it kind of rings the bell saying, hey, something is there, there's some problem there, and this may point at the problem. So what alpha indicators, in other words, biomarkers,
left brain, decrease in left brain alpha activity would indicate depression. I remember that. Okay, so alpha was, it was actually the opposite. It was more active in the left, and it would indicate depression. So it's a bit twisted, you know, back to front. I know it's because you'll see beta kind of there and alpha there. So beta consciously, beta is conscious part, right, of our mind. So beta will be kind of sitting in the right, and alpha will be sitting in the left. And beta in the right will mean beta right is taking negative messages. So it means beta consciously is able to take only negative messages. And that means what? That means we are, of course, will be depressed, gloom and doom. And then
And then if it's the other way around, it's just could indicate emotional disbalance or anxiety, mood regulation. It's another story. So
like would that be over arousal?
No, arousal means not left and right. Arousal means how we go through frequencies, high frequencies, low frequencies. The faster the wave, the more alert you are. The slower, the lower the wave, the more sleepy you are. Because remember, beta, conscious mind, you're fully awake, you're fully alert. Alpha is the state, as I said, it's good. It's beginning of coordinates. It's beginning state. You wake up and you are in alpha, and you go to sleep through alpha. So first state when you wake up is alpha, and last state before you drift to sleep is alpha. So it's kind of your reference, beginning of coordinate state, opening the doors state between conscious, subconscious. So that's and then theta we'll talk next time. Then I'll announce the next webinar and continue with this subject because I have everything ready. So theta would be REM sleep or daydreaming, or we are drifting deeper, right? It's already deeper. And then delta will be deep sleep. So obviously on arousal, beta is fastest, delta is slowest, and it will indicate how far we go. And arousal will also affect what? Our attention. Our alertness will affect our attention, how attentive we are. So obviously another, I would mention two biomarkers. One is on eyes closing, whether we are, whether we are able to let the guard, conscious guard, go and look inside without any trouble, or there is so much suppressed stuff, so much trauma, so much charged emotional stuff there. It's too hard. So we'll keep blocking it. No, we are not looking. It's too scary to look in there, to dive into subconscious. So that's when somebody can't open alpha, it can indicate anxiety and trauma, hidden trauma, suppressed stuff. Too much alpha sometimes can be, as I said, sign of anxiety as well, just restlessness. And then another one is the dominant frequency is slower than 9.5. This brain is a bit slow. So what's going on? It's under-aroused. And again, there could be many reasons for that.
Sluggishness.
Yes, exactly. It could be something chronic, or it could be just lack of sleep, or like why this is happening. But this is something to pay attention to. And especially with age, with older age, it will decline and go down if we don't keep ourselves mentally engaged and pushing the limits.
Can we add creativity? We didn't mention it, but will synchronized alpha give creativity?
Yeah, but now, I mean, maybe it would be a good idea for us to go to the very beginning. Since I'm closing this topic for now, I'll stop here, not to overload. It's enough for now. Give it in chunks, to give this information in chunks here. Do you see that what I just described does make sense and explain why we say what we say about alpha brainwaves? Gateway to subconscious, is it? Sensory awareness. Any comments, creativity? Okay, yeah, welcome. Add anything you like for yourself and for everyone else to help integrate what we learned.
I'm sorry to have so many questions, but I'm so excited. So where do gamma brainwaves, which are very high frequency, where do they come in? I heard Judith speaking about gamma. Like at a certain point when coherence is achieved, gamma is like a super conscious kind of beyond.
Let's say we'll talk about gamma next time. For now, I'll say gamma is normally seen and very often even attributed to higher frequencies of beta. So at a certain level, I should say beta stops being about anxiety and panic and disorganization in your brain, just flashes here and there, right? Again, in primitive language, but it gets to another level of binding information together. So you kind of have this quantum leap or your quantitative frequency leads to another qualitative level. So you shift the quality of how your brain operates, because gamma will be able to cover large areas of the brain and deeply interact with the memory. So gamma talks a lot with theta, and theta will be about memory consolidation. So gamma will basically bind and take your whole function on another level, giving you laser focus, extremely productive, working memory and memory in general, helping you to get more connection with, again, talking deeper, better, more efficient use of memory. It's like understanding the context better. So you quicker react, respond, find the right behavior, right way out. So that's gamma. But we'll talk about it maybe next time, because next time, obviously, beta, gamma, and then maybe, I don't know, it feels like it's more than one program. It's probably 2 more programs to cover all the brainwaves and not overload. Just take it gradually, step by step. But yes, to be continued. Yeah. I
have a question about the books. The first one, the protocol guide. I went on Amazon and it's out of print. Is there?
No. You go EEG info. This is Orthmus. Do you see this EEG info in the corner?
Yes.
So there is electronic edition. You can always just in 2 clicks. It costs about $50, and from EEG info, this is the training platform, the information platform of Orthmus. Susan Orthmer, and you can get electronic copy, the latest one, at any moment. They'll just send you the link, and then you access it online and find whatever you want, to take pictures. Etc. And even more, I can tell you, because I was looking, first of all, I have hard copies of all of these books, but then for the presentation, obviously, I needed pictures. So I thought, no way I'm going to pay double price to get pictures. So I found electronic library that actually has a free trial period. And then it asks you $8 to $12 a month, depending on the plan, where you can access these books. And surprisingly, I don't know, I found there these technical foundations of neurofeedback. I found 2 cooperative books, Functional Neuromarkers for Psychiatry and Quantitative EEG, Event-Related Potentials and Neurotherapy. I found these books there in this library.
You're talking of scribd? Is this scribd?
No, it's Perlega. The amount of information that I passed through my brain in the last 2 weeks, 3 weeks is incredible, not counting what I was what I had been reading before that point, before I started preparing for presentation, just during my course. It's unimaginable. So
it's much appreciated.
So I'm just saying that I did it for my own good in the first place, because you know that the best way to learn is to teach it. And that's what my motivation was behind. But guys, remembering, I was thinking even I should do a paid course, because it will complement what Judith is teaching. But then just somehow realized, no, I'll just do it. I'll just do it no matter what. So if you at any stage decide that you want to say thank you and donate something, whatever amount, I don't care, it would be nice. It would just nice. Use my email and PayPal, whatever you think is fair. I don't care really, but it would be nice. Thank you to me, because I was like, I'm doing such a great job. I was searching for information online, and it's Awaken Mind training, the one that you receive all reminders from. Thank you so much for your attention, all the comments and participation. So thank you guys, and see you next time.